send people to live on Mars permanently. So he will be starting his talk right now.
Yeah, I got checkity. Does everyone hear me more or less? Okay, yeah, good. So my name is Zach Trolley, and I'm going to talk to you about Mars, Mars One, why I want to do it, why I think it's the most amazing thing anybody could possibly do with their life. So if you want to as well, go feel right ahead to join up. And I'm going to be answering any questions you have. I'll be here after the talk. I'll be outside later tonight. I'm going to post some of my contact details, so if you think of something later, by all means, ask me any questions you might have. So I'm going to talk to you a little bit about myself. As a kid, I got one of those the night sky books, and it had the stars and the planets and the constellations, and I was looking through the planets as places to go, as places to visit. And I moved around when I was a kid into different places, and I ended up in Calgary. I graduated from Western Canada in 2002. I went to SAIT. I got my technician's degree in 2004. Worked for a few years, went back to school to Lakehead University, graduated there in 2011 with an engineering degree. And just this past summer, I was with the International Space University with their Space Studies program. Now, that's the resume part of who I am. But during all that time, I was looking at things to do with Mars. I was a Mars geek. I was following the missions, what the rovers were doing, the information that was coming back, and it was all about that. I would talk about it, I would think about it, I'd watch the movies, and then Mars One came out with their application that says, who wants to go to Mars? And I actually got a few emails from my friends that said, if you don't put your application in, we won't believe you. You have to put your application in because you've always said you want to go to Mars. So I did. That was December last year. There was 200,000 people that put their application in. As of today, there are 705 left, and they're going to be picking between 24 and 40 of those people in the coming months. Interviews start in December, so I'm pretty stoked about that. So here is our neighborhood. This is where we live. These are the places that I would look at as a kid and imagine going to. These are destinations. This is our solar system. We've got 4 rocky planets and 4 gas giants. And here are the inner planets. Earth is the biggest. Venus, Mars is about half the size. And you have a few of the moons of Saturn and Jupiter. Mercury tucked away, little old Pluto, way down the list there. And these are places we can go to. These are places we can put feet on the ground to. These are places one day we can live. So here are, again, the resume facts about Mars. It's about half the size of Earth, 38% the gravity, 1% the atmosphere. It swings to about minus 40 during the nighttime, a balmy 20 degrees during the hottest day on the equator in the summer, so it's not a tropical planet by any stretch of the imagination. But whenever I tell people about this and show them, again, the resume facts, it becomes very unbelievable. People doesn't seem like it's possible. And I show them this little factoid. This is, of course, taken in Kitty Hawk during the first powered flight, and 66 years later, we landed on the moon. 100 years ago, you couldn't buy a plane ticket. You couldn't buy a plane ticket to Europe. It was impossible. Now, anybody in this room could be going to Europe tomorrow, and I wouldn't think anything of it. It would be completely normal. Imagine being on that field in 1903 and telling them in 70 years the US will be going back and forth to the moon regularly. Would have anybody believed you? One of the Wright brothers said, if we worked on the assumption that what is accepted as true is really true, then there would be little hope for advance. Months before they took this flight in 1903, people said it was impossible. You can't do it. It can never be done. And now we've gone to the moon. And now you can find people all over the place that say going to Mars is impossible. Well, I don't believe them at all. One of my professors at the International Space University was Jim Dater, and he studies futures. In that there isn't one future, there's many, and we can choose the one that we want. We can plan for the future that we want. And any useful statement about the futures should appear to be ridiculous. Because if it sounds normal, then it is, and everyone's doing it, and it's not new. So new things sound ridiculous. So saying that now, I'm going to tell you the plan for Mars 1. So in 2015, coming up, they're going to have their crew selection completed, and they're going to start training that crew on the mock-up habitats. How to enter, how to exit, how to live, how to work with each other, how to deal with the isolation, all these things, all these skills that we need to learn, how to be farmers, geologists, maintenance workers. That will be completed through 2015. In 2018, they're going to land a lander on the surface of Mars to do several technological tests. One of them being, we know there's water on Mars. Can we distill it to be drinkable? So if we can't drink the water on Mars, it's going to be kind of a problem. They're also going to test solar panel technology and several other technologies going to make it possible for us to live on the surface of Mars. After that, they're going to launch rovers. Now, these aren't the rovers that we're used to seeing. These are more Tonka trucks than science vessels. They're going to be working rovers. They're going to be bulldozing. They're going to be looking for places to land. They're going to be clearing landing pads, spaces for us to live, so you don't land on a crater or a boulder or quicksand or anything like that. And then we're going to send landers with cargo in them, based on the same principle that we're going to launch people. So we're going to try it with cargo several times to make sure we know exactly what's going on before we send people in. And that will be all the cargo we're going to need for the first crew. And these rovers will actually be able to hook things up, to drag the modules together, to deploy the solar panels, and set everything up so that everything's going to be ready for us to go before we launch. So there's somewhere to go when we get there. So it's not, oh, there's 5 hours of oxygen left and 10 hours of work to do. Hopefully we'll get your thing set up really quickly. No, we're going to have somewhere to land and to go before we leave. And then in 2024, they're going to pick 4 people, 2 men and 2 women, to launch to Mars to set up a permanent colony one way. Then we're going to get there, we're going to set up, and we're going to be preparing for crew 2. And this is going to complete until there's 24 people living their lives on the surface of Mars. Now, of course, I get, when I do that spiel and very versions of that talk, I get, the inevitable, why are you doing that? That sounds very silly. So I'm going to try and answer a few of the whys for you to give you an idea of why I think this is important, why I think we should be doing this. Now, we have rovers on the surface of Mars. They're exploring right now. They're doing amazing work. We're learning things absolutely every single day from these robots. So why should we send people at all if they're doing the exploring for us? They don't come back. They don't get hungry. They don't have families. Just keep sending robots. So here's a map of Mars and the landing locations where NASA has sent rovers. There's the InSight mission. That's a future mission plotted out. And I'm going to focus on Opportunity. Opportunity has been a fantastic little rover. Here's where it landed. This is a mineral map of the area where it landed, where it's exploring. Now keep your eye on the Endeavour crater. We're going to zoom into that location. Whoops. So this is the path that it's been taking. It's gone past the Victoria crater into the Endeavour crater and along this area, and it's been doing this for over 10 years. This is the path that's been gone through since 2013, and it's gone quite a ways. It's actually the rover that's gone the longest on another planet that we've ever sent over. And it was designed for 90 days, and it's been going for about 3,800. So it's been doing pretty good. And here's another view of where it's currently situated. And again, it's traveled over 40 kilometers, but that's over more than 10 years. And that's as far as it's gone in 10 years. Now, I know there are people in this room that could probably go 40 kilometers in a day. I'm sure everyone could make it in a week. It's taken it 10 years to go that far. Robots can't guess. Robots can't use their intuition. They have no gut feeling. They can't have imagination. They don't go off the path to check out something shiny over there. They do what they're told. They have a very specific mission. We miss out on a whole part of exploration by sending robots. Now, if you keep a look on your eye on the Endeavour crater, and you look at the map now, it's lost. Mars is half the size of Earth, but because it doesn't have any oceans, it has about the same land mass. There's a lot of area to explore. And if you look at the bottom left part of your screen, there's a dark blue circle there. That's the Hellas Basin. It's almost 2,300 kilometers in diameter and 9 kilometers deep from the top to the bottom. And that's an impact crater. That somewhere during the history of Mars, a massive object slammed into the planet and left that huge, huge hole. And if you look to the left, there's that red-white hole area there. That's the Tharsis Bulge. That's 5,000 kilometers across, 7 kilometers high. That's all volcanic activity. There are the 3 white dots on the left side of the Tharsis Bulge. Those are all 3 sister volcanoes. Each one of those is larger than Mount Everest by at least a factor of 2. The other white dot that's a bit further on to the left, that's Olympus Mons, the highest volcano in the solar system. It's 22 kilometers high and about the size of Arizona. These are locations that I would love to visit, right? I mean, that sounds pretty awesome. It's 22 kilometers of elevation on a ski hill, that is a long ride. These are the vacation properties of tomorrow, absolutely. If you look onto the right side of the Tharsis Bulge, there's that massive canyon that extends to the right. That's 2,000 kilometers wide in parts and 7 kilometers deep. I mean, people talk about the Grand Canyon in the United States. That thing stretches all the way across the United States. That's a canyon. And it extends out into this massive blue area up to the northern hemisphere that is devoid of craters. And it's devoid of craters because that's the ancient Martian Ocean. And its history, the meteorites would not hit the surface, it would hit the water. And that's why you don't see impact craters. And we've sent landers there to dig, and there's ice just a few centimeters under the dust through that whole expanse that we hope, we think, we haven't checked the whole thing yet. But it's going to require people to do that. People to make those distances, to use their intuition to check these places. And when we go, myself, I would like to see families on Mars. And that's part of the one way. The Apollo missions went and they touched the moon and they came back, and we've never been back since. And there are lots of plans to send people to Mars. Most of them are return trips. We send people out, 6-month trip there, they spend 2 years there, and 6 months back. Now, if we didn't do that with the moon, instead of setting up Skylab in the 70s, we actually created a moon base. Hatfield would have been playing his guitar from the moon base instead of the International Space Station. And we'd be living in a very different world than we do today. Staying is very, very important if we want to stay there. We didn't stay in the moon. So there's lots of places to explore. But that's only one part of it. We want to stay there. We want to settle the planet. We want people living there. Now, the Mars 1 mission is rustic. to say the least. It's not high living. It's not a luxury suite. But the Apollo astronauts were pooping in bags on their trip, so it's not a luxurious life to say the least. However, we do want to stay. We want to make things better. We want to grow towns. We want to grow cities. And at some point in the future, we want to have metropolises with their own culture, their own arts, where people live and they flourish, and they have their own economy, their own ways of living. And we need to stay there for that to work. And there are two companies right now that are working on the space economy and setting this up. When I talk to kids, I tell them, and I'm telling you just the same, right now you can get a job as an asteroid miner. They're prospecting asteroids today. And to make this work, you need customers. You need people to sell these things to. And that's the chicken and the egg problem right now. They're out there, but we don't have any customers. And once we do, everything changes. In 66 years, we went from flying our first airplane to touching the moon. In the next 66 years, we could have people graduating from high school and going to their guidance counselor and asking to become a space miner. Long-haul truckers to Jupiter. The lunar resort director position might be open. These are all possibilities that we could do. I mean, everyone is carrying an AI-controlled supercomputer with the knowledge of the human race in their pockets. That's something that the original Star Trek didn't even have because it seemed ridiculous. But now we drop it in the toilet by accident and buy a new one for Christmas. If we do this, if we get to Mars, and if we kickstart the space economy, the next generation, and I'm not talking about way down the line, I'm talking about the generation of kids that walk in these doors every day, they will have technology and abilities that will seem like magic to us. It will be completely beyond anything we've ever known. And that is an amazing thing, not just for Mars and for space, but for Earth as well. So then people always ask me, well, why would you go do all that on Mars when we're ruining Earth right here? We got the environment to worry about. Everything's going to crap. Why are you doing that? And it's about reaching for stretch goals. Space requires an enormous amount of international cooperation. NASA, among all the offices in the government of the United States, holds more international treaties than any other organization. Just because it's necessary to run space, you have to work together. That's part of how it works. International cooperation helps bring peace, helps us understand each other. When we reach far, when we go outside of ourselves, we come to new goals and new ideas. There's no other way to get out of the box thinking than to literally move outside of the box. On Mars, we'll need brand new ideas, new ways of doing things. Not just because it's a harsh environment, but because it's a completely alien environment. There's different chemicals there. There's different atmospheric compositions there, temperature swings, gravity. We have no idea what the effect of gravity will be on people for that prolonged period of time. None. It might be fine, it might be not. We don't know until we check. Your thinking will change. You'll get new goals. You'll reach further. All this new technology will be created. New ways of doing things, new ways of thinking. And all those things will spin off to you and me, to everyone else, and we'll get to use these devices. People will come up with new ideas, new sketch pads. Things that we thought impossible, we'll start trying. And then we'll start implementing. We're moving about an alien planet, trying out new things, and bringing those findings back to Earth. And when we do, there'll be a new host of things that will become possible on our planet. Right now, we hear a lot of limited resources. We're running out of this, we're running out of that. Earth has a resource problem. Humans don't, because we can leave Earth. The universe has all kinds of stuff in it for us. The imagination has no limits. And if we start taking limits off everything else, who knows what's possible? Who knows what future we can create for ourselves on Earth? What kind of buildings we can make without limits if we didn't have to worry about all the things we worry about today. Nobody's worrying much about whale oil anymore. You don't see many horse farriers worrying about the automobile taking away their jobs. We've just changed. Things have moved on, and things will do so in the future. And of course, planet Earth will be better because of it. And then people say, well, why would you want to leave Earth at all then? Just like when I was a kid, if you look at all those points of light on that picture, those are also destinations. And those stars have planets of their own. And we're not going to get to those planets until we can get to our own solar system and learn how to travel in between that. And Mars is the first step to being able to do that. Once we can get to Mars and learn how to live there, we can learn how to figure out our entire solar system. Once we figure that out, then we can literally travel to the stars. And this is, of course, a journey. It's through uncharted waters. This is something that's never been done before. We have no idea how it's going to work, how it's going to go, and what's going to go wrong. That's kind of the fun part of it. I mean, we could stay here and we could be safe in our homes and not worry about it, but that's not the point. The point is to stretch, to reach, to travel, to look, to find. I mean, learning to live on Mars is absolutely a risk. All things are risks. Risks is how you get a date with a hottie in the bar. Risk is how you make windfall returns on your investments. It's how discoveries are made. And the reward for going to Mars is literally the stars in the sky. This is our neighborhood. This is our home. This is where we live. Earth is where we were born, but this is still all our neighborhood. These places we can go to and we can touch. We can put our feet on them. We can walk around on them. I mean, just yesterday, we landed a lander on this comet right here, the Rosetta mission. And it harpooned and it wheeled itself in, and it landed on this comet. And it's only 3 kilometers across, but that's what it looks like on the Toronto skyline, 3 kilometers across. And what's inside that comet? I mean, what if it's all resources we could use? What if it's an iron rich? What if it has platinum, gold, silver? What if we could use all those resources and build an entire city with it? Take all that resources we have out there and build colonies. We could support millions of people with those resources. With all the resources out in space, we could support trillions. I want to add cities and roads to this map, not just points where we sat down of interest, of scientific intrigue. I want it to look like a road map that we pull out of any gas station. I want people living there. I want resorts and towns. I want to go on that 22-kilometer drop on my snowboard. That would be something. I want to make these cities. I want to help create them. This is the key to getting to the stars. We need to learn to expand past Earth. And our only limit is our imagination, and we just need to practice our imagination. Like I said, in 1903, they had the first flight. And now anybody can take a flight from the very old to the very young. You just buy a ticket and you get on. Now my dream is to one day that travel between the planets to be just as mundane. That you'll have grandmothers taking their grandchildren on trips to see people across the solar system. And if any were to tell me today that you're going to go do that, I would shrug my shoulders and say, well, that's fine, okay, and it to be normal. And that's what I want my normal to be. So thank you very much. If you have any questions, I will be here to answer them, and I'll be outside afterwards.
And we can actually take a few questions here right now, if that's okay with you.
Yeah, is anybody brave enough to speak in front of everyone and ask your question?
So if you want to put your hand up, I can come up there with a mic and hopefully see you. And then, oh, there we go.
Hey, what do you think of the prospect of terraforming Mars?
Terraforming. Fascinating. Now, it's a science we don't really understand very well. In effect, I mean, climate change is us terraforming our own world by accident. Mars has 1% of the atmosphere. We need to thicken up the atmosphere. That's actually the easy part. The hard part is warming it up so it can sustain liquid water. And that is many, many years away. Lots of people like to think about it. There's ideas on the board, but no one really has the idea how to do it within a time frame that anybody in this room will be alive for it to see it happen. Ethically, we'd have to try and find out to see if there's life on Mars first and see how it's adapted to its current environment before we start changing it to something else.
Great. Any other questions? Here we go.
How much would this project cost, and who's funding this project?
They don't send me their balance sheets, oddly enough. The estimate for the mission is $6 billion for the first 4, and then $4 billion for each subsequent 4 after that, which sounds not like very little amount of money. If you ask NASA, it's anywhere between $450 billion and $50 billion for a mission to Mars. The devil's in the details with that. The NASA mission includes orbital factories, moon bases, entire armadas of spaceships traveling to and from Mars. Mars 1 is the kind of the old Volvo version of that mission. The MIT study that you may have heard about that came to the conclusion that the first death would happen in 68 days. Actually backed that price up. They said the launches to get that much mass into orbit would cost about $4 billion. So we got a thumbs up from MIT that the numbers are right. As for where they're getting the money, again, they don't share their balance sheets with me, so I don't really know. Well, it is privately funded. I mean, it's a non-profit corporation, and they're trying to get the money up front to launch it, obviously. But again, if you want to ask Brian about that later, he's outside with the stuff. He has all the answers. Putting you on the spot.
How many people would you send to Mars on the first trip?
On the first trip, there are 4 people and on the Mars 1 plan. Now, the fun thing is, once Mars 1 sends the first 4 people, there's no one stopping the Chinese from sending 1,000 or the Indians from sending 100,000. I mean, the Indians just showed up NASA when they sent their probe. First time they got it right for 1/10 of the cost. So they might be the ones doing it instead of a North American-centric mission. We'll have to wait and see. The Mars 1 plan is 4 people every 2 years, every 26 months.
Usually the first thing that happens is somebody plants a flag. What's the first flag going to look like?
It depends who funds the mission. It could be Bill Gates' face up there. I don't know. The Warren Buffett family heirloom. I mean, the interesting thing is, I mean, when I was talking about some of the names on Mars, they're all very Latin and fancy sounding. The people that start living there are going to name things on their own, right? That spot where you always trip over, that's the fuck you spot now. It's not anything special or normal. That's what it's going to be. So as people live and they adapt their environment, I'm sure they'll take on names as they go, which is much different than exploring, planting your flag, and going home.
Great. So I've got one question here and then one question up at the back there, and then I'll take one more after that.
Once you're up there, what if you do change your mind?
It's one of those things you can't really change your mind about.
Isn't there a way back, though? I mean, have they thought of that?
In the Mars One plan, no, there is no way back. If you saw the outpost sketch, we're actually taking the spaceships Atlantis there and modifying it to be our habitat. So it's like sailing over and decommissioning the ship to build your houses with. Now that being said, Elon Musk of SpaceX is looking to create a settlement of his own on Mars. He plans on selling tickets for $500,000 per ticket to get there, and there's going to be empty vessels coming back. So he wants to set up a Earth-Mars railroad, and if you happen to catch a ride on his railroad and do the book tour and all that stuff back on Earth, then that's up to you. Another quick point on that, like I mentioned, we don't know the effects of the Mars gravity. We know what happens in zero gravity to the astronauts in the International Space Station. They spend a lot of time training to maintain their muscle mass so they can come back to Earth. For that prolonged period of time, if we're on Mars for 10 years, our bodies might change that makes it impossible to come back to Earth. The gravity might kill us. We don't know.
Hi. First of all, let me say much respect to you for involving yourself in this. My question is, what's the plan for dealing with the radiation levels on Mars, both inside the habitat and outside?
So the one way to mitigate radiation, the problem with Mars is that because the atmosphere is so thin, a lot of the shielding that our atmosphere does for us doesn't happen on Mars. As well, it doesn't have a strong magnetic field, doesn't really have one at all. So it doesn't deflect a lot of the cosmic rays that comes onto the surface. When we're in the habitat, we're going to basically bury it. So it's going to be covered in dirt, which give us enough volume, so that should absorb the radiation. For outside, it's going to be something we're going to have to limit exposure to. The NASA estimate, I believe, is for every 3 years you spend on Mars, your rate of a fatal cancer goes up 5%. So that's just one of the risks that you take going to Mars. And we'll obviously try to limit that as much as possible. On Mars, it would be possible to teleoperate robots, so we could drive them on the surface and not having to be them autonomous. So we could send rovers up there and we could drive them on the surface, or we could have larger vehicles that are shielded. And as the technology improves, we'll find different ways of doing it. But there is a risk, and it's just one of those things that you live with when you're doing this.
Great. So I've got the last question up here. But as Zach mentioned, he'll be around for the rest of the evening. So feel free to approach him individually.
You were talking about families on Mars.
Yes.
For the original 4 people, the 2 men, 2 women, when would they be able to breed?
So the Mars One plan does not have any breeding in the plan. It's just going to be a sex for all. That's all it's going to be. There are 2 reasons for this. One of them is we only have enough resources for those 4 people. And if you all of a sudden have 5 people in it, it becomes very difficult to manage. Outside we're planning out our living quarters. If you have 2 people in there and a baby, things get kind of intense. The other thing is we don't know how women will carry pregnancy in those conditions. And every person on this crew will be very important. And we don't want to be doing unnecessary risks to people that we don't have the ability to absorb. Like I said, once Mars One proves that it's possible and paves the way, the Chinese might send 1,000 with room for 500,000 to grow. Who knows? But for the Mars One plan, there are no children in the Mars One plan.
Great. Well, thank you very much, Zach. And as he mentioned, you can check out the program that he and Jeremy Caron of the Planetary Society and Brian Versteeg, who's done a lot of the renderings for Mars One. They're all running that, and they are all very well versed in what's going on. So you should ask all of them questions. Thank you very much.
Thank you.